It is day 4 of online learning, so this video is for March 20th, and it is about Unit 6, Lesson 1.4. So we're still going and talking about fractions, but today we're going to be talking about how different fractions can be equal to each other, and that's called equivalent fractions. We've been using rectangles like our brownies in our first lesson and the fraction sets that we've been using for the past 2 lessons to represent our wholes. But one whole can be any shape or size. So let's say that this yellow pattern block is a cookie. And yesterday, you figured out ways to make one whole with your fraction sets. Now this cookie is our one whole. How can we make this cookie in different ways with other pattern blocks, like our trapezoid, our blue rhombus, and green triangle pattern blocks? How can we use these different shapes to make one whole? So what I would like us to think about first is how many blue rhombuses or pattern blocks do we need to cover our whole yellow hexagon cookie completely? How many red pattern blocks? How many green pattern blocks? I want us to figure out how can we use these shapes to make a whole. So if I'm going to start with first my blue rhombus, I see that there's one, and I can just flip it by touching the corner right over here. To make sure it fits perfectly. So how many blue rhombuses did I need in order to fill up my yellow hexagon? You said 3, you're right. I needed 3 blue rhombuses to have one whole hexagon. So if I had 3 parts, what would my fraction be? 1, 2, 3 parts that make up my whole, and it's divided into 3 different parts. So my fraction would be 3 over 3 would equal 1 whole yellow hexagon. So now I want us to think also with our red trapezoid. How many do you think that it will take? So I see that I filled, right now I have 1/2. So how many more will I need in order to make my whole? I'll need 1 more. So I have 2 trapezoids that make up 1 whole hexagon. So if I have 2 pieces that make up my whole, if it's broken up into 2 parts, I have 2 over 2 would equal 1 if I was talking about the trapezoids. 2 trapezoids, and if I break this into 2 parts, that would be equal to my whole. Now I want you to think about how many triangles will it take. I have 1. This one's going to be a little bit trickier since I have to move them.
2, 3.
So what's my fraction that's filled right now? Right now it's filled half. It's half of my trapezoid is filled.
2, 4, 5.
So how many pieces did it take to make my whole here? How many parts? For my triangle, I had 6 parts that made up my whole. which is equal to 1. A little bit easier for myself, I made it color coordinated so you could see the red trapezoid. If I had 2 red trapezoids, that's equal to 1 whole hexagon. If I had 3 blue rhombuses, that would be equal to 1 whole hexagon. And if I had 6 green triangles, that would be equal to 1 whole of my hexagon as well. So what I want us to think about right now is, what if I had 1 trapezoid, what is my fraction of my yellow hexagon? What's my fraction that would represent how much is filled, or what is my part right here? If you said 1/2, nice job, because you can see that 1 trapezoid fills up half of my hexagon. What about if I did the same thing with just 1 rhombus? How much is filled here if I just have only 1? I know that I would have to divide it into 1, 2, 3 parts, and I only have 1. So my fraction would be 1/3. What about if I put 1 triangle? I know that 6 triangles equal 1 whole hexagon. So what would my fraction be for 1 triangle in my hexagon? It'd be 1/6. If we were to think of these as parts of a cookie, because my hexagon is my whole cookie, we can say that the red piece represents 1 out of 2 equal pieces of a hexagon cookie, so it would be 1/2. My trapezoid, or my blue piece, would be 1/3 of the cookie, and my triangle, or my green piece, would be 1/6 of a cookie. So if each of these is 1 part of this cookie. There's different ways that I can fill my cookie with my different pieces and have it different. So let's say if I had 1/2, let's see if I could bring a 1/6, another 1/6, and another 1/6. So let's see, I have here 1/2, and then 3/6, and they fill up the same amount. So what that makes me think is that I have 1, 2, 3 pieces, and how many would it take to fill up my whole? And take 6, because that's my fraction. How many that I have of my green triangles? I have 3. It would take 6 to complete my whole, is equal to 1/2. I see here that 1/2 is equal to 3/6. And I could even check it by putting them on top of each other. I could see that they're equal to each other. So we were just saying how 1/2 is equal to 3/6. And we figured that out because 3 triangles made up half of my hexagon, just like 1 trapezoid made up half of my hexagon. So this is our work from yesterday that shows ways to make 1 whole. But what I wanted to keep doing is show different ways that we can figure out that 1/2 is equal to 3/6. So what I'm going to do is make my fraction bar And in order to be a fraction bar, they need to be the same size, just like our sheets of paper need to be the same size of our whole. That way we make sure that they're even throughout. So I have 2 fraction bars, and I'm going to do 1/2, so 2 equal parts, and that's 1/2. Now what I'm going to do is do 6 equal parts, and I'm going to draw a line down the middle, then split this part up into thirds, so 1, 2, 3, and then this part into thirds. It's not even, I want to make sure, because in order to be a fraction, it needs to be equal parts. And now I'm going to color in 3/6. So 1, 2, 3. Here I have 3/6 of my fraction labeled in. So here I can see pretty easily that 1/2 is equal to 3/6 because I have 1/2 and then 3/6, and they're the same amount of my fraction bar filled in. Today we did different ways to make one whole, and those all had the same denominator. Now I want you to think about what combination or equation can represent this combination of fractions. I'm going to erase this so it's out of our way. What is an equation that can represent this combination of fractions? And I'll let you pause me now. I want you to think about what can I be adding together to show this combination of fractions. I could break it down and say 1/6 plus, I'm sorry that this is messy, it's kind of difficult to write on here. 1/6 plus 1/6 plus what? 1/2 is equal to my whole. So my whole. So if I had 1/6 plus 1/6 plus 1/6 plus 1/2 covers up my entire whole. I know it's kind of hard to see. How can I simplify this a little bit and make it easier for myself to see? There's a different way that I can also add it using my 1/6 and my 1/2. I can also write 1, 2, 3, 6 plus 1/2 equals what? What does my 3/6, my 3 green triangles, plus my 1/2, my red trapezoid equal? It equals 1 whole. So what we were just talking about is different ways that we can have equal fractions. And equal fractions are called equivalent fractions. So let's see if I can figure out a different way that I can make an equivalent fraction, or something that is 2 fractions that are equal to each other. So this, if we remember, my trapezoid is 1/3 of my hexagon. Let's see if I can use my triangles to equal the same amount that the rhombus has. Let's see if it takes up the same amount of space. So I see here that my 2 triangles, so my fraction would be, because remember it needs 6 to fill up my hexagon. So 2 triangles are equal to 1 rhombus. And I could double check that by seeing if they line up perfectly with each other. And they do. So what I see here is that 2 triangles that need 6 parts to make up my whole, so 2 6 is equal to 1. And how many did it take for my rhombus to make that whole? 3, so 2 6 is equal to 1/3. So what we're talking about is equivalent fractions. And equivalent fractions mean fractions that are the same. We could figure that out in a fraction bar or see if it fills up the whole the same way. But it's when 2 fractions are equal to the same amount. So we already figured out that when we did our triangles and our trapezoid, that one equivalent fraction is 1/2 is equal to how many triangles? 3 triangles that needed 6 total. That's one equivalent fraction. We also just talked about another equivalent fraction, and it didn't complete the whole, but we figured out that 1 rhombus, which would be 1/3, because it took 3 rhombuses to make up my whole, 1/3 is equal to how many triangles? It took 2 triangles to have the same amount, and it needed 6 total to have up my whole. So here are 2 equivalent fractions that we figured out together. Show us that you understand what equivalent fractions are. Remember that equivalent means that the 2 fractions are equal, that they're the same. So what you're going to do is shade in the fraction shown, then write equivalent if the 2 fractions are equivalent. If the 2 fractions are not equivalent, write not equivalent on the line. So I'll show you an example for this first one. If my fraction is 2/4, I would shade in 1, 2 parts. Sorry, it's kind of hard to draw online. So I'd shade in 2 parts, 1, 2, because it's 2 parts of my whole. And then for 1/2, I would shade in 1 part. So now I'm going to think, do these 2 fractions show the same thing? Is my whole covered the same amount on both? And I can tell that yes, it is the same amount. So they are equivalent. So I would write on the line is equivalent. And you're going to do the same thing throughout. So along with the worksheet with equivalent fractions, you also have a worksheet that is having you practice multiples of 10. So please make sure you show your work and also write down the rules of each problem. I would like both of those worksheets sent to me for my class. If you have any questions, please reach out and contact me, Ms. Palermo, Ms. Antoine, or Ms. Spears, and we'd be happy to help. Thanks.